Today's class is on ductless installation and maintenance. So we are not going to get into super specifics here. We're just going to sort of do an overview on some do's and don'ts, some processes. But yeah, we'll just sort of jump right into it. So to start off, we have our class overview. We have our installation side, and then we have our maintenance side. To start off with our installation, we have our key points of installation. These are the points that we really want to slow down on. With installation, just like with anything else you do on a repeated process, you get used to it, becomes sort of a rhythm. You sort of zone out, get comfortable with it, more of a muscle memory in some cases. But it's important to remember the key points, those points that you want to slow down on, because if you're not paying attention, they will bite you in the butt. So going over those key points, going over some best practices, whether it's pulling a vacuum or doing a pressure test, there's a right way to do something and a not so right way to do something. So here at Kalos, we like to do it the right way. So
that's right.
I'm glad we're spending
That's right.
So best practices.
Just so you know.
I don't have a ton of slides, so I'm going to spend extra long on all these here. Going over some common issues. We'd all like our installation to go nice and smooth, but it never happens to go that way. So going over some common issues to expect. And we're going to do some hands-on demonstration up here pretty soon. But yeah, that'll be the installation side of things. Next, we have the ductless maintenance side. We're doing a step-by-step maintenance process. For those of us who have maintained regular split systems, it is a little bit different, so knowing where to start and where to end is important. Testing the equipment, for the most part, it's pretty similar to a regular split. However, there are some steps you want to take in order to fully test the equipment. Drains, like regular systems, we have the indoor unit that condensates water. That water goes somewhere. Where does it go? Well, you came to the right place. We'll be going over drains. We have pump maintenance, run into a lot of pumps. It's important to keep them clean, maintained, avoid issues. We have our blower wheel cleaning. There's a big difference between someone who knows how to do a cleaning and someone doesn't, and that's 30 minutes and 2 hours. So knowing the right way to clean a blower wheel will help on efficiency and profitability, right? So pay attention to that part. And lastly, we have the coil cleaning with the bib kit. A lot of the ductless work we like to do is going to be non-invasive if possible, light cleaning when we can, but in some cases they get pretty nasty. So being able to do that cleaning with the kit is going to be important. And then at the end, we'll have some common customer issues and a little Q&A. All right, ductless systems. We got a little quote here. Man, nothing gets my big brain going like ductless systems. YOLO. That was old Albert Einstein himself. Yeah, one of the best technicians in the field. But yeah,
What does YOLO mean? I don't know what that means.
It means you only live once. So that's my mindset with ductless units. But yeah, a lot of ductless units out there, whether it be a cassette in the ceiling, whether it be a pancake unit, a VRF system, stands for variable refrigerant flow. Plenty of applications for them. However, today we are going to be going over one in particular, and that's going to be the wall mount systems. It's the most used in residential for many reasons. They can be installed in bedrooms, enclosed lanais. In some cases, multi-head units can be installed all across the house. So really nice units, quiet, energy efficient, easy to maintain. So customers love them for that reason, and we are going to be focusing on that today. Components of the ductless install. So we have our head unit here. It's where your evaporator, your blower motor, and where your drainage starts. So that's all located at the indoor unit. On the back side, we have our condenser, our pad, right?
Is that locked or something?
No, this is how it only turns one direction.
Okay.
So outdoor unit, we have our fan motor, outdoor coil, compressor. We have our EXV, electronic expansion valve. And then moving down the line, we do have our high voltage here. Unlike a regular changeout, a lot of these units are from the ground up installation, so we do have to run power from the breaker panel through the attic down to our condensing unit, and then from our condensing unit to our indoor unit. So we have our high voltage, and then we have our drain, whether it be a gravity drain or a pump of some style. So pre-installation checklist. Before you actually go out and install one of these units, it's important to go over your checklist. So to start off, we want to review the scope of work before leaving the shop. So that's going to be beginning with the comfort advisor or the technician who was originally on site, going over the equipment, whether you're going to be looking at some photos or a site map, just having a full scope of the work before you actually leave the shop. Next is going to be reviewing the van stock and supplies. We want to avoid having to leave the job site for any reason to any supply houses or to the shop, so making sure you're fully stocked up for the day.
What are some common things that guys forget to have on their truck when they're going to go do a ductless install?
Well, the most common things would be those materials that are regularly used, such as refrigerant, line hide. Obviously, you shouldn't be leaving that behind the actual system itself, or that's a problem. But any reusable materials, Capcons, small stuff, insulation, UV wrap, just things that you're going to use on every install there.
Right breaker.
Huh?
Then split adapter.
Adapters,
Yeah.
Oh, yeah,
the line hide adapters too.
Yeah. All right. Once on site, you want to go over the full scope of work with the customer and review the proposal with the customer. It's important to remember that we are going to be spending all day at this house. A customer's home is their private, safe spot. And it's important that they trust you, that you present yourself in a professional and clean manner. So that first 15 minutes are important. You know, you want to develop that relationship with them. It's the first time they've seen you. So introduce yourself, go over the full job, go over the equipment. It's important that everyone's on the same page as far as what's happening that day and what to expect. So that's sort of the overview of the full scope of work.
And you're getting that verbal approval that the condenser is going right here. Like this is what you talked about before, just making sure that we're on the same page. Because you don't want to set something and then have a customer really care about after you've done all the work of placing somewhere that actually I wanted it 6 inches over here or something. So like this is going to go here, and then the inside unit, oh, you haven't gone there yet?
No, almost. Yeah, so the actual placements of the indoor and outdoor unit is important to go over. Indoor unit considerations, is it on an interior wall, exterior wall? You know, the positives and the negatives of both of those. You know, where the hole is going to go, if it's going to be an exterior wall and you're going to punch through, what's on the other side of that? Just getting the full scope from beginning to end so everyone's on the same page is important. So that's the inside and the outside. Lines and drain hole placement and pitch. If it's going to be a gravity drain, do we have enough space above the air handler to ceiling to actually have a gravity drain? We don't want to install a unit and punch a 4-inch hole and find out we can't actually run a drain line there. So planning this all out will avoid some heartache. And last but not least, read the manual. Whether this is your first ductless installation or your 50th, going through that manual, reading the specs. You know, when they put this thing together, they weren't just throwing it together, they actually thought it through for the most part. So knowing the manual,
phrase is for the most part.
knowing that like the back of your head is really important, so I'd recommend it.
Also, you have the fact that we're mostly talking about the wall mount here, but like if you're doing a slightly different application than before, that's another important thing on the manual. And then the manual for the service side, I don't have a slide that says read the manual on the maintenance, but they have such fantastic manuals online. If it's like Mitsubishi, you can go to MyLink Drive, and they have service manuals that tell you like where the screws are to take stuff apart. Like doesn't matter what you're replacing. It could be a board, blower, motor, wheel, coil. Step-by-step process with pictures in those service manuals on like all your major ductless manufacturers. So.
Yeah, we should have made a slide having that all up there, but y'all get the idea.
It doesn't matter if you're doing the install or you're doing maintenance. Like if you're doing maintenance work, you're working with cleaners and like something that's been in a customer's home, so their dead skin cells are on that unit, whatever it is. Just protect your eyes and your hands if you're working with cleaners. And then on the install, you're doing a lot of heavy stuff and you get used to doing it every day so you can get more careless. But like there's drilling through the wall. Safety considerations for yourself are really important. Also, when you go to drill a hole, like what's on the other side here? Is there a breaker panel literally on the other side of this wall? No one would ever drill through that and hit a breaker panel. Yeah, so yeah, think about those things.
Best practices and common issues. I sort of touched on those key points you always want to pay attention to. These are the key points here. So flares are a big one. Common callback are leaks on flare joints. They may look okay, but over time, through vibration, expanding and contracting of copper, leaks do occur. So slowing down and following the correct process for that is important. Next one here, you have the pressure testing. Again, refer to the manual to what pressure the manufacturer recommends. Quick rule of thumb, over 300 and under 600 is a good rule of thumb, but again, refer to that manual on that pressure test. Setting the charge, like regular split units, these units do come pre-charged, so knowing how much to add, if any, is going to be important, especially since they have such a low charge, so we'll be going over that. And then again, drains and pumps. Just some best practices with those, some considerations with those. All right, making flares and pressure testing. So here we have a couple slides on the proper way to make a flare. Just a few key things we want to point out here. Just to start off is the actual reaming process of deburring the inside of that copper. Whenever you use a copper cutter and you make the cut, you do get that lip on the inside. And if you don't deburr that lip, you tend to have a pretty bad flare. So we'll do a little demonstration here on the proper way to make a flare. Now there are a couple different tools you can use. In these cases, because these can cause such headaches, I would recommend using the best tool. In this slide, we obviously have a manual flare tool here. For this demonstration, we will be using a battery-operated flare toolkit. Really nice to have because they are pretty precise. There's not a lot of thinking you have to do with them. You just sort of clip it on and go to town.
It's also worth mentioning, this is not the latest version of NAVAC flare. They actually have two. This is the earlier version, the newer one. I don't remember the model number off the top of my head, but
Yeah,
it's a little more compact.
this is a little bit of a later, but this one is actually really great still.
It's really great, yeah.
Yeah.
And it's still sold.
The newer one
It's
can
just-
get in some tighter areas. That's one of the changes on the newer one, a little bit tighter areas. Okay, so when you're cutting copper and you're cutting your edge, this blade, it pushes into the copper in order to form that cut, right? So then you have a little lip on the inside that curves over. And if you just stick that straight into your flare gun or your flare tool and you push that out, that lip gets smashed. Well, it's a point where there's going to be ridges and cracks. Now, on the inside of your perfect flare, there's going to be ridges and cracks. And so it's a point that you can actually have leaks. So that's where the deburring tool comes in. You actually have to go in there and cut out that lip. Now, take your time on this, paying attention to what you're doing. If your copper is sitting like this and you start using the tool, little bits are just going to fall straight down in there. So you want to adjust your copper to where it's got a little bit of a downward angle. And usually there's a line set attached to it, right? So a little bit of thought into that. Don't just lose some. So as you're taking off that edge, you want a nice clean edge in here. You don't want to get so much off that you actually create a thin spot on the copper. You're just taking that lip off. And then once it gets down to where the rest of the copper is, and you're done. All right.
It's also worth mentioning, there's a couple different kinds of deburring tools. One looks like a little cone that you place in there and you twist. And then ultimately, if you don't have one or whatever, you can actually use needle nose pliers and just place those into the end and just kind of flatten out that burr. I haven't had good luck with that, but a lot of really smart people do that. So, if you're in a pinch, that's worth trying.
Okay, important. You actually need to have your flare nut on the copper before you do the flare, or it won't slide on. It's super frustrating, and not backwards. You know what I mean? Like this would work for this side, but I'm going to turn that around. And with the NAVAC swedge kit, super easy. You slide it in, and it has a little guard right here. It'll stop the copper as deep as it needs to go. And the reason for that is that you want your flare angle to actually match the nipple on the other side, not to stick further out into the threads, not to be so short, that you don't actually have a lot of surface pushing together. So this actually has a guard on it, which is another reason why these are so great. So you have to push it against that guard, and then you know you're at the right depth. Tighten that down.
Which is similar to when you're using in step 4 on the illustration, it shows a guard on the manual one as well,
Okay.
or whatever you want to call it.
Yeah.
A guard is the right word, a stop,
stop.
that's the wrong word.
A stop.
It is a stop there, and that will kind of get you at the right depth.
Okay, so then I'm going to go forward into the flare. You can hear when it's finished, and then back that back out. If you want to make sure when you're backing it out, you take it all the way back. Another feature with the newer gun is you just push the button, it takes it all the way in and back out for you. You don't actually have to control it manually. That's the newer version. And then your flare joint. Before you hook up your flare, you want to inspect your joint and actually make sure that it's beautiful. And so you can just give that a visual inspection. You go around that top edge, don't have any lip that's been folded over and pushed in and cracked, and it's smooth. And you slide that up against the nipple that you're going to, make sure that the width here, it covers the face of that. It's not sticking too far into where the threads are. It's not too short. And before you tighten down, you want to line this up perfectly so that the copper resting is sitting right on that nipple, right where it should be, instead of like pulling away. So as the years go by, the system's running and vibrating, and that backward pressure is just pulling against there, and it can crack the flare or pull it out, create a leak. So there's your flare making demonstration.
A couple more points on that, little helpful hints. Adding a little bit of nylog to the threads or to the copper keeps it from binding up. And then on the same topic of the proper tools to have, carrying a torque wrench and setting it to the proper specs is always nice. I think we're all used to just giving it the old field test, but using the torque wrench is probably the better idea. It's not probably the better idea, it is the better idea.
It is the better
Torque
idea.
wrench by Hillmore.
Couple things to mention. Sam said placing it on the threads of the flare. Really, the back and face of the flare are the areas that you really want the most. A little bit on the threads is okay to act as an assembly lubricant, which is really what we're using it for here. It's not so much thread sealant. A lot of people get confused nylog with things like True Blue or other types of thread sealants that harden. That's not what this is. This is not something you're going to buy at Ace Hardware or Home Depot. This is a very specific product made with refrigerant oil. It will affect your torque specs. That always comes up. People always point that out. But again, we've done it. We've used it for a long time and still continue to tighten to spec, and we have good luck with that. So another thing to mention, the torque wrench that's shown in the photo here is not a digital torque wrench. It's actually one that utilizes, it's manual, and so it just gets to the right torque and it does that clunk clunk motion. If you've ever used a traditional torque wrench, those also work perfectly fine. The one that's shown here is a yellow jacket that's designed specifically for flares. You can use a traditional torque wrench with a claw feature on it, with a crow's foot connection on it, but you just have to make sure that you're not extending the length, and so you would actually have it at 90 degrees. So rather than having it straight out, that would extend the length and actually change the torque setting, whereas this yellow jacket one is actually designed for that. So again, with a torque wrench, it's always really important that you hold it by the handle. If you change where you hold it, you're actually changing the pivot point and changing the end torque that you're producing.
All right.
And this is probably the number one reason that we get called out to just random ductless systems. There's a lot of people installing their own or calling their maintenance guy to install a ductless system or something, and flares leaking are probably the number one reason we get called out to a ductless system. So system low refrigerant.
Another note, because some people will say like, well, this procedure looks good, but where do I find it later? All of these procedures are available on the HVAC School app. So if you go in the HVAC School app and you go into the part that says checklists, that's right. I forgot what it was called in my own app. They have this here as well.
Oh, that's your app?
I didn't want to bring that up. That was just accidental. That accidentally slipped.
All right, next, insulate, insulate, insulate. So, one difference between a ductless unit and a regular split. Regular split, you have your 2 copper lines from the indoor to outdoor. One's insulated, one is not. One is cold, one is not. On a ductless unit, they're both cold. You have a suction line and you have the expansion line that run from the indoor to the outdoor, or vice versa. The EXV is located inside your condensing unit, so on the other side of that, you have that liquid vapor mix heading back to the indoor unit. And because both lines condensate, it's important to pay attention to any nicks, tears that may occur. A lot of these times the copper is running overhead through the attic, and as you're pushing it, it's getting caught on roofing nails. You're opening it up to do a flare and connecting it. It's always important to remember to re-insulate the entire line from beginning to end. No one wants water leaking up in their attic. So pay attention to that. It's a big one.
Also keep in mind, thumb gum and cork tape do not have the same insulation factor as actual Armaflex or whatever, tubing insulation, whatever you want to call it. So make sure that you have tubing insulation going all the way to the end. And when in doubt, wrap it with additional tubing insulation, or sometimes multiple layers of foam tape can be used in place, but don't just pack thumb gum or cork tape around it and expect that to keep it from condensation.
Yep. Many service calls where we've gone out for something leaking and we haven't been able to pinpoint, exactly what's leaking. Is it the pump that's failing? Is it a connection point? A lot of the time, it's just a small section of something that's getting to dew point and condensating water. And it doesn't happen right away. A lot of these leaks happen over hours of runtime. So if you're in that position, keep that in the back of your mind, condensation.
Pressure testing after you've made your perfect flare is still really crucial and important. So just actually getting the nitrogen up above 300, around 400 psi is good, because those flares are going to be in heat mode, and that your psi is going to be pretty high in heat mode on all of those flare joints. And so you can, if you actually look at the data tag, they have your low side, high side pressure, design pressure on here. So typically you want to go somewhere around the low side for pressure testing, but if you look at the manual, they'll often ask you to go even higher than that to test those flares. Put bubbles on them every time. So when you put bubbles on the flare, you do a nice smooth coating on that flare, and you let it sit for a little while. If you don't see bubbles right away, you can come back to it and see if there's any active bubble action going on there on those joints. Now, oftentimes they're a little hard to get to the bottom side without a flashlight and a mirror. So always have your flashlight, your mirror, right there with your little bubbles when you're testing that. And in the meantime, the system is sitting. You're watching the PSI to making sure that it's not actually dropping under that pressure. And then you're safe to go ahead and hook up the vacuum. Now, vacuums on a ductless system is such a small area, they'll pull down really quickly, which is great. That's nice. You take out your Schrader core. The vacuum and the pressure testing is universal for all the systems that we work on, so we didn't develop a step-by-step slide for you guys on that. We have all of that in articles, videos, and HVAC school checklist, so you can check that out. But best vacuum practices are really important. People are buying these kits online sometimes and just hooking them up and putting them together and creating their own problems with their electronic expansion valves seizing up because there is moisture, there's crap inside the system. So a vacuum is still a really important step, and that decay test will also let you know. It can be your guarantee that there's no issue with your flare joints.
When it says high side and low side pressure, keep in mind this is a heat pump, which means that everything that's outside that condenser is actually always going to be on the high side in heat mode. Mm-hmm. So when you're pressurizing outside the equipment, that's why you can pressurize over 320. In fact, most manufacturers recommend it. You would not go over 600 psi. But again, remember the weak point on a system, almost every system in terms of pressurization, is actually the fusite plug on the compressor. The compressor shell is actually low pressure, and that's what you don't want to pressurize to that higher pressure. So if you're pressurizing inside the condenser on the low side of the reversing valve, i.e. the compressor shell, you wouldn't want to pressurize that over 320 psi. But the rest of it has to be designed for the high side pressure, because in heat mode, the indoor coil is the condenser. Mm-hmm. Does that make sense what I'm saying here? So in heat mode, that inside is going to see that high pressure anyway, so it is on the high side of the system.
Mm-hmm.
So they kind of make it confusing with that. Another thing that I want to mention with bubble testing, Bert talks about this a lot in other videos. When you are spraying bubbles on, you don't want to just spray willy-nilly and create a bunch of foam that then makes it difficult to tell if you have leaks. You want to put it on very flat and then actually let it sit and look for those little micro bubbles, especially on flares. On flares, really pay attention to your flares. Don't make sure we don't have leaks because you don't insulate, and make sure that we don't have even tiny leaks with flares.
As far as needing to add any refrigerant, it is stamped right on the data tag on how to do that. Can't go by subcool or by pressures usually. You do have to go by the line set length. So if we look at this data tag here, we can see if the liquid line exceeds 25 feet, we need to add 1.8 ounces of additional refrigerant for every 5 feet. So knowing how much line you're actually using is going to be important here. And again, a reminder, these units do not hold a lot of refrigerant. This one only holds 2 pounds. So if you find yourself adding over a pound, trying to get your pressures to look good, something's wrong there. So make sure you slow down in this part of the process.
Also keep in mind your hoses can hold several ounces of refrigerant. So that alone can impact a critical charge like this.
Yeah, you got a full tank, your hose can hold like 3 ounces of refrigerant, and then your manifold and maybe your other hose involved in the mix, you could have more than you need just in your hoses.
Which is a reason why I don't like doing it how it's shown here with the big old gauge and multiple 6-foot hoses on it, because that makes it more difficult. I would rather see us do it with the shortest possible hose, probably one 6-foot hose or even a 4-foot hose, and a probe setup, so that way you're not having all that additional charge.
Once you've bled your hoses, then reset your scale, and you have that ball valve right there, so you can open it up and anything happening on your scale is what's going in past that point right then. You shut the ball valve off, and then you've saved the refrigerant that's in your hoses. So you're not worried about that extra refrigerant going into the system. And then you won't be wasting extra refrigerant if you use a small line and just hook straight to the tank. But
Aaron Ward has a question.
So the one big thing with finding and making sure you have good flares that I found out that really works is whenever you're doing a vacuum, that 10-minute isolation test is going to be the big factor. I mean, bubbles and all that work really good, but to find those kind of really small leaks in your flares, that's going to be the biggest tell sign for it. And also whenever you're looking at trying to figure out how much to charge, Mitsubishi is the only one that tells you on the data tag. So you're gonna have to read a manual if you're working on any of these.
Yeah, and again, it's actually, this is pretty basic math. It's the amount of refrigerant that the liquid line can hold per 5 feet. So you can actually use the charging calculator on my site as well. But then you wouldn't necessarily know what the initial line length is for that manufacturer. So you're not probably going to get away with it with not reading that manual. But when in doubt, you can look it up on our app. Chad says the micron gauge will always tell, which is also kind of supporting what Aaron said. For those of you who don't know how to do a proper decay test, this is again where using less lines, only using a single vacuum hose, and then valving it off and seeing if it decays. That's really a good practice when you're doing vacuum. You want to have the minimum number of connections, the shortest possible hoses. For vacuum, the largest hoses that you can have, and then that micron gauge, seeing that decay is really going to tell you. If you don't know how to do a proper decay test, then you're going to get really frustrated. Just similar to what we talked about just today on doing a decay test directly on your micron gauge. If you've ever tried to do that, if you ever tried to valve off a micron gauge with a ball valve and see what it does, the thing jumps sky high in the matter of seconds. And it's not because there's anything wrong with the micron gauge. It's because there's such a tiny amount of internal volume that you're pulling a vacuum on in that case. So what we're saying is here, you take a little tiny hose with a little ball valve in your micron gauge, you hook it up to the pump, you pull it down real deep, you valve it off, and you see how quick your micron gauge rises. Just do it sometime. The thing will just go bananas on you. And it's because there's such a tiny internal volume and everything leaks. Every ball valve leaks, every seal leaks, your micron gauge itself leaks, everything leaks. So the more volume that you have behind it, the less that speed is gonna be there. So the smaller the volume, the faster it's gonna change, which is why in ductless systems, if you have a ductless system that passes a 10-minute decay test, it's pretty tight because the internal volume is so small. If you do the same test on a 5-ton unit, it's going to decay less because there's more internal volume that you're pulling a vacuum on, if that makes sense. Which is why on things like VRF systems, where you have miles of copper tubing, they make you do multi-day pressure and decay tests because there's so much internal volume that if you have a leak, you could have a hisser and it's not going to show up because there's so much nitrogen in that system, if that makes sense, over a shorter period of time. So in ductless, if you pass a pressure test, you pass a bubble test, and you pass a decay test, you don't have a leak. Now, it could still leak later on because of a bad flare connection. Like we said, over time, they can still create leaks.
Gravity drains and condensate pumps. Depending on the application, you'll be going with one of these two. If you're installing a wall mount on an exterior wall, the best thing to do is to install a gravity drain for a variety of reasons that we'll get into. But it's not always possible to do that. So, in the case where you are on an interior wall, condensate pumps are going to be the next best option. They make a variety of pumps with different functions, but they all basically do the same thing. Water fills a reservoir of some type, it triggers a motor and pumps that water outside. So we have a couple of pumps here that we like to use a lot. We have the orange Aspen, I believe it is here, and also the white Aspen. The orange Aspen is generally installed on the inside of the head unit here. You can pull this unit slightly forward and it is installed up on top of the lip on the back side of the unit. And sometimes if we have a line set that comes off the unit, it can be installed in the line set as well. That is the reservoir location. The motor location can be inside the line set, or in some cases it can be up in the attic itself. Now these motors do tend to make a noise, so you always want to be aware of location when installing these pumps. But we'll get over the benefits of each one here. So the gravity drain benefits, we have less maintenance. We're no longer talking about a small reservoir that gets filled up with gunk. We're talking about a 3/4 inch pipe that's draining outside, so less maintenance is needed on those. Less noise for obvious reasons. There's no pumps running on a gravity drain. Lower chance of water damage. These lanais are installed at various locations, often above electronics, furniture, hardwood floors. So when you don't have a chance of a pump failing, then less chance of water spillage. So lower chance of that, and they just generally look better. This unit here is installed with a gravity drain, so you don't have any additional line height on it. You don't have a pump underneath the unit, so just for the aesthetic of it, it looks a lot better. So that's for the gravity drains there. Benefits of the pump, none. No benefits really. I mean, if you don't, you can install the head in more places with the pump. However, it's basically the opposite of all this. More maintenance. You're going to deal with the noise aspect of it. When they fail, you do tend to have some water leakage, and you're generally going to see something that comes with it, whether it be a pump sitting directly under the unit or some line hide going up into your attic. So placement of the head is important, just because the drainage aspect of it.
So a couple things here. First off, when you do maintenance, you have to clean the reservoir. That's a big thing. Another thing is we usually use copper for the discharge. Copper is highly conductive. For the longest time, we didn't really bother insulating them, but it's still cold water. And so if there's any water standing in there, then in some cases it's not much, because in many cases you're kind of pumping it up and then it's draining out periodically, so it doesn't actually get cold and condensate. But we really should be insulating these drains as well, because again, it just depends. You don't necessarily always have to, but it's a good best practice, especially if it's running through an attic that has a 90-degree dew point in some cases. And another thing is, don't run chemicals through a condensate pump. Don't run hardly any chemicals through a condensate pump. It's usually going to destroy them, except the very most mild. And then even when you do, make sure you run fresh water through to clear them out. So like for us, using the EVAP Plus properly diluted, you could run some of that through there, but I wouldn't even leave that in the reservoir. It's just that they're very sensitive to cleaners.
We'll get a little more deeper into the actual maintenance side of things coming up here. So thank you, Brian. All right, so we've completed the installation, done all of our proper processes. The last part, and a really important part, is closing with the customer. Explaining full operation, what to expect, can avoid some unnecessary phone calls and unnecessary return trips. First one up here is just going to be the remote operation. We won't get into super detail as far as the actual settings of them, but a couple key points on them. One misconception is that the remote itself is what's measuring the temperature in the space, because it's actually showing what it's set to. That's not the case, however. This unit is actually measuring the temperature at the head. So you need to properly communicate that to the customer. A lot of the times they just like to fiddle with it and not actually point it at the unit. But it does use an infrared beam to control the unit and requires you to actually point it at the unit. So when in doubt, turn the unit off and turn it back on again to make sure it's still operating. Another one is the battery location of said remote. It requires you to pop the case completely off, which reveals the batteries. I believe they are 2-year runtime on these batteries, so every 2 years might start getting dim on you, might completely turn off. Got to replace them, so knowing where that is important. Next thing up here is the blower operation. A common concern that comes up is that the blower never shuts off on these units, and that's the case with many ductless units. Now, as previously stated, the unit does measure temperature at the unit head, and in order to properly read that temperature, it continuously runs the blower motor, circulating air past that sensor, in turn constantly running that blower motor. So that's the design of the unit. If you want to shut off that blower, you have to shut down the unit completely. So that's a common question. Maintenance, how often do you maintain the system? How often do you clean the filter? Well, we'll talk about that next. I'm not sure why we put that there. But maintenance is a question. And again, I want to say it again, pump noise. Whether we're out quoting the ductless, whether we're installing the ductless, having those conversations about the noise level of these pumps is important. The customer may say that doesn't matter to them. However, a lot of these units are located in a room with a TV or a reading area or someplace they just want to relax. And when that pump kicks on every 5 minutes, it can get pretty loud. So properly installing them, there are some tips and tricks you can to quiet them down, whether it's putting the motor in a noise-proof ductboard box that we've seen. Helps a little bit with the noise. You want to be cautious of overheating the motors in some cases. So whether it's insulating it or hanging it, keeping it off trusses, just to try to dampen that noise as much as possible. Always being aware of that and properly communicating it during installation.
Aaron Ward has something else to add. Go ahead, Aaron.
Thank you. I've noticed a lot when having to install the pumps, they have a shutoff and they like you to split the S wire. And I've noticed that whenever you split the S wire and it's longer than about 40 and 50 feet, you run into a lot of communication problems with the unit. So you guys keep that in mind when working with it and trying to find other ways for that automatic pump shutdown when it's not draining to save water damage, and how to get it to work differently. I've used it and changed it to cutting off power completely, but that's something that you really got to pay attention to.
Yep, so per the install manual of, let's say, the orange condensate pump here, between the indoor and the outdoor unit, you have a 3-wire high voltage wire. You have 2 legs of 120, and you have a communication wire that the units communicate with. So per the manual, you want to actually break that communication wire with one of the gray or purple wires here. So that way, if the pump were ever to clog up or potentially fail, if that reservoir rises to a certain level, it'll actually break the communication to the unit and shut it down. So what Aaron was saying is if the actual high voltage line is long enough, which is what I'm kind of understanding you were saying, they can cause some random communication issues, tripping that off. So keeping that in mind. It is a nice safety to have, especially in cases where the unit is above anything important. So,
in our application too, Britton pointed this out to me earlier, that you can tie your safety in with the dehumidistat, because we are putting them in with dehumidistats actually there, so that they are set up as dehumidifiers. And when people use them in their lanai instead of actually a fully AC'd conditioned sealed space. And so you can break the wire from the humidistat, so it's just another option for breaking it. So you could hook it straight into that.
Okay, so that sort of wraps up the installation side of things.
When you're mounting a head unit, is it important to say you're drilling through a block wall? Is it important to pitch that hole so that water drains from inside to outside?
Yes, it's actually on our slide.
Oh, it is? I didn't see that.
Yeah, I didn't actually go over it, so that's probably why. Yeah, so whenever you are installing a unit on a exterior wall and you are looking at doing a gravity drain, having that hole pitched downwards going outside is important. Water flows downwards and you don't want it flowing inside the house, so pitch it downwards heading outside the house. And again, height restrictions inside is a big aspect of that. You know, where you're going to put the unit, always think ahead before actually cutting that hole.
In order to service this, we got to be able to pull this off and raise this at an upward angle to unclip this. So if it's so tight right here that we can't actually get in above here and unclip the clip-ins, it can be a nightmare.
Yeah.
There's also a spec that gives you a minimum.
Yeah, it actually says in the manual.
Yeah.
I got a good question.
Yeah.
How can we attach the drain line that comes with the unit to the outdoor PVC?
Fantastic
Glad
question.
you asked.
So we have the factory piping that comes with the unit for drainage. Per the manual, they don't actually give you anything or show you anything on how to actually connect it to a pipe. However, the exterior of this insulation fits pretty snug into a regular 3/4 inch coupling. So what I would recommend is using some type of sealant, some kind of waterproof caulking around the insulation, and then inserting it tightly into a said coupling, letting that dry before you actually put any water through it. If you have a portable hot glue gun, that works too. There's no exact right or wrong way to do it. However, anytime I've done that, it's solved any kind of leaking issues. But anytime you're working with any kind of drain connection points, spending extra time slowing down, making sure we're getting those connections tight. Don't make any cuts on this pipe unless you know you have everything in place. What tends to happen is we make a cut and then go to connect it and find it's a little bit too short, can't quite fit it deep enough inside that coupling. So just make sure everything's in place before you cut anything.
Glad you guys are here. Glad that all of you are going to be sticking around for the next 45 minutes to an hour for the maintenance section. Actually, maintenance on ductless systems on a well-maintained system, can actually go pretty quick. So less than a half hour as far as training goes on this. So we're gonna go for that. However, they're also notorious for becoming really nasty. So it's important to have regular maintenance, keep them all clean. Once they get really gross, there's a lot of extra work that goes into cleaning them because they're so compact, right? So the things that can get nasty on them are the coils. That's where you get your complaints about smell. The customer is smelling something when it comes on. It's typically there's some sort of algae growth happening inside the coils. And the bib kit is perfect for that. You can actually use pressure cleaner and washing it out. Blowers, you guys have all seen the blowers gunk up. They get pretty nasty. Drains and pumps, huge one. We're going to be going over each of these individually. And the pans can gunk up and they can actually clog at the little exit port right where they hook up into the drain right here. And you have this buildup that can happen over time and then break loose and just clog right there. So I've seen that several times. Cleaning out your pans is important. So let's jump into all of these things then. The first step in every good maintenance is quality customer service. And so like Sam said, showing up, you're in the customer's home, this is important to them, and they need to feel recognized, heard, and see that you care about their space, you care about them. Everything else that you do after that point, whether you run into problems, whether you have an opportunity for some upgrade conversation with the customer, whatever it is, it's all going to go much smoother for you when they actually trust you and see that you care. So fake it. Ask the customer questions about their system. Okay, how's it working? How's the unit been working since we were out here last? Do you have any concerns? Is there a problem that I need to know about before I get started on here? Always ask those questions. Even though you would love to just go figure it out on your own, they need to be heard, but also understanding what their concerns are beforehand allows you to address them properly. So, protecting the customer's home, shoe covers, drop cloths in the space. These are installed inside your interior space typically. So, air handler might be in a garage or in a closet, and you can feel more free on that maintenance. But this, like, you're in their personal space, and it's right above typically stuff that can be damaged, so be mindful of your surroundings. Move customers' things out of the workspace. Don't be sitting there doing a maintenance right over a couch, okay? And that usually means that you're probably not using water or cleaners and stuff anyway if you're not making a mess on somebody's couch, or you're just a lot cleaner than I am. I pretty much always am making a mess. So move some stuff out of the way carefully, not to break anything. Lay a drop cloth down in the workplace. And this sets you out as someone who cares, as someone that can be trusted in their home, and who's going to do a detailed job right there. So once that's done, you can wrap up, leave the customer's home, and customer service is what it's all about anyway. Hope for the best with the equipment. That's a lie. I was just kidding. It's not all about that. It's not all about the show. And this isn't a show. Come on, guys, care.
Yeah.
Once you care, you're going to enjoy it.
People don't care how much you know until they
Till they see how much you care.
know how much you care. Yeah, no.
I said it right.
When you say see how much you care, that doesn't
Oh,
work.
until they know how much you care. I
How
got to
much
use
you
the
know,
no
how
again.
much you care, yeah.
Okay, come on, please, I'm trying. We're right in. Go over the scope of work. I really like this on a maintenance because you add value to what you do. The customer might not be watching, but just quickly letting them know I'm going to be cleaning the drain, or if there's a pump in the side, I'm going to be cleaning the pump, be cleaning the coils, checking over your equipment, adding value to what you do. Great move right there, all right? This is your maintenance process.
Water tower out back.
Develop a process, stick to the process, always deliver, or something like that. Pre-inspect the equipment, so get eyes on everything. How does it look? Turn it on and actually make sure that your system's running. If you notice any issues, communicate with the customer before you start your cleaning process. So if I could just slide this over here. Let's pre-inspect. Let's just confirm operation non-invasively, making sure the system's running and you're not seeing any red flags before you are opening the system and doing stuff that maybe the customer feels like, hey, it was working great until you got here. I mean, what'd you do? You know what I mean? So find out major issues that could be going on, communicate with the customer about them. If they're there, you got to shift gears to problem solving instead of cleaning. But typical maintenance, you pre-inspect, you communicate any issues, you clean the system. You're always going to confirm again after you've cleaned and taken everything apart that your system is operating the way that it should, and you communicate with the customer what you actually did in closing the call. Again, important. Okay, so let's just go straight into testing system. Ductless system that's working well can be tested actually pretty easily. You're going to want to make sure that you turn the unit on at the full stage so that the compressor is actually running full speed, and that's the only way to accurately check your readings. The easiest and most simple way, this is what I use on a maintenance to know if your ductless system is working, is to take a temperature split, and you're typically going to be between 25 and 30 degrees, and like almost always 28. Like it's a pretty consistent temperature split when you're dealing with normal temperatures inside the space. Obviously that can be different if the unit's been off and it's really humid and really hot. Again, on a regular AC system, our target is at 20, right? Like that's the rule of thumb that you always hear. But if you've got a ductless running full speed and you got a 20-degree split, you have a problem with your charge. Something's actually going on. It should be closer to 27 degrees when you split. So
You don't just necessarily have just a problem with your charge. It could be other things as well.
so the only issue would be your charge.
That's-
And it's
No,
leaking
it's
in
not.
the flare joint.
No. I feel like we're.
That's it.
I know.
Okay.
All right, fair.
There are other potential problems. You'll have to call tech support for those.
Tech support is Bert's number. which
Always
will be
just
in the
try
show
adding
notes.
refrigerant. Okay, as you're doing this run test on the equipment, you're looking for red flags that would take you from your non-invasive check to actually needing to hook up to the system and check your refrigerant and check your superheat. Now, if you're using probes, you're not going to lose a lot of refrigerant hooking up to the system, right? Especially if you have a proper straighter depressor tool on the end of that or a low loss fitting. That's great. You can hook up to this, but typically when you're testing a mini split system, you don't want to hook up a gauge. You don't want to hook up manifolds and hoses. We've already talked about how much refrigerant that can hold. You go and you service a system, twice a year for 3 years, and this thing's going to be low on refrigerant because we've been checking it every time. So a non-invasive test, we got a great split. We don't have a reason to be concerned. And then the story from the customer is also that it's working good. Great. Red flags. This is when we're going to be hooking up. We have a warm suction line. Why is a low split? Oh, it is on there. Low split. We see ice forming on the expansion line. Now, I have seen a system that's been sitting off for a really long time. You first turn it on, a little ice is there, and within a couple minutes of run time. So, as with everything else, you turn your system on, give it 10 minutes. Did I write that down? Wow. Give it 10 minutes to run before you check. So if you got ice on your expansion line, the liquid line that comes up in, the smaller line, that's a real clear indication that you are low on charge and it's actually starting to flash and freeze right after the expansion valve.
Again, not necessarily only low on charge. You could have a
So
screen
again,
or
low on charge
other-
is the primary issue.
always thinks it's only one thing.
In the last 10 years, it has been a electronic expansion valve like once or twice. So seriously, and there's no way to know that, ever.
It's impossible.
Unless you do some test.
Right.
Yeah.
Or weigh the charge out.
Weigh the charge out.
Yeah.
Okay. Yeah, this is not a diagnostic
Oh, okay.
service call.
Great.
This is maintenance.
Maintenance.
Another sign would be sloshing sounds at the air handler, like when you first turn it on, you hear the refrigerant. Not when you first turn it on, but when you're in there and you've turned on the system and you still hear this just sloshing going on in the refrigerant, that is a typical indication that you are low on charge on that side of your system. Okay, now it's time to clean. I like to do run tests before, unless you've actually looked at the equipment and you see it's really dirty, it's filthy. That's going to affect your readings, right? You can't trust your readings anymore. We're changing our process up. We're just going to test operation, but then we're going to do all of our testing after we've cleaned, right? But on your typical maintenance on a ductless system that's well maintained, let's do our run test before we take everything apart and do cleaning. It's just a time saver. Okay, so wash your filters with water, and your condenser coils don't typically get that dirty unless you're in an area of really high dust. Commercial applications, barn.
Animals,
The barn.
like my dog who lays up against it,
Yeah.
gets real dirty. Dryer vents, gets
Dryer
real
vents,
dirty.
animals,
Yeah.
barnyard.
Dirty children, in your case.
No, the dirty children do not get the condenser coils dirty. It just doesn't happen. Wow. Only use cleaner on that coil if needed. If it's really impacted and you're not going to be able to get it clean, then use cleaners. A condenser coil cleaning, and that's fine. But typically water, rinsing through that, you can get it clean. So then next you're going to be removing the air handler panel.
Oh, this is my part?
I did this. Were we supposed to talk about that? Next you're going to be removing the air handler panel when you're doing the maintenance for better access to what you're cleaning, which would be your coil and also your drain pan, right? So let's do that.
And blower bill.
And blower wheel.
What's a blower wheel? Nah, I'm just kidding, guys.
Am I doing this or
Yes,
you
you
doing
are.
this? Okay.
Yeah, we're actually in a time pinch.
All right, so
Okay, so we have little tabs on here that just slip out. And then these veins are actually marked upper and lower on there. So you can see which one they go on. Thankfully, they're level, so you don't really know what upper and lower is. But on the back side, there's a notch that only fits into one of them. When you put it back in, and then you slip it up in place, and you push your, I already did that. You push your tabs over. All right?
all right, and the next part here, down at
I'll
the
do the talking. The next part here, so you have tabs that cover your screws. You pull them out. Some models will have screws here. Others will have a couple extra screws on here. According to the manual, you want to pull the bottom out until these clips unlatch, or they're at least free enough to be pulled out. Now, one of my favorite things to do when actually pulling this is you take the cover plate off the, oh, it's already off the side. This cover plate unclips. We got a couple clips here that pull out, and then you can grab onto the bottom of this plate. So down here we have a couple screws, or notches. You're not going to be able to see it with that, but there's 2 arrows here, and it clips into the back plate in that spot. I like to use a little metal piece that I've bent to have a flat edge, because some of these are so tight on the wall you can't get your fingers behind to unclip that. But if you slide it up underneath here like this, then you can bring it along the wall and pull it off of that notch, and then pull the air handler out a little bit. And this can be a bit tricky. It's almost impossible to not look like a noob to the customer during that part. So like that one right there would have been, it's really tight against the wall sometimes. That can be pretty hard. So that little tool helps.
It sounds really noisy.
So-
Like something's breaking.
Do you normally do it this way?
No, no. I went straight into the pump.
Okay.
I forgot that we're actually taking the cover plate off, and I haven't gone to my pump slide yet. Okay, so let's just take the cover plate off first. I'm sorry. I should have done the whole thing myself. I don't know why I asked for Sam's help. I'm so sorry. First, we're taking off the cover plate.
You just skipped over a pretty good part there. What did you just do?
Okay, so on the bottom, the screws have been taken out. It just pulls out on the bottom. Okay, just grab it and pull it out. Is that the part I skipped over?
Yeah, just grab it and pull it out, guys. You everyone got that?
Thank you.
All
So then you slide out like this, and you'll start to hear the top unpop. And then there's notches that it slips in like this, so you push down on the top to get it out a little bit further. Don't break it. You always feel like you are going to break it, but you won't. You'll never break it.
You see how loud that is?
It is.
Yeah,
But-
every time. Right?
Yeah, don't jerk and look around insecure in a customer's home when you're doing this. Please, confidence. You're going to hear that every time. Gravity drains versus cleaning pumps. And I'm actually going to start on the cleaning pump side. I know it's not typical for people to start on the right, but that's because once I've done some of this, we'll be pulling the unit apart more. So when you have a pump application, you're going to have the reservoir up underneath inside of this right here, and it's going to be super tight to get to. And cleaning it, about the only way to do that, is that still unlatched? So take the bottom off. You guys, they have a nice little tool for this.
There it is, your bent piece of metal.
Little flat end. So typically, in order to do this, you have to pull the air handler out slightly. Now, if this connection is loose at all, which if the drain runs along sideways, which they often do when they're going into a pump, this is not a pump. The drain's going straight back, and I can't really pull back on the air handler. Whereas with the pump, the drain comes along the back of this and hooks onto this, and you have a little bit more room. Typically, your lines come up here in a line hide that you've opened up, and you can rock the air handler slightly back. And when you do that, then you pull the reservoir down, and you let the air handler just sit like this, and you have access to everything that you need to clean right there. So,
You literally did unclip it from the back plate. That's what you intended to do?
yeah.
Okay, okay.
Yeah.
I've never seen this before.
Okay.
Yeah.
Now, you do have to get to that pump. There's no other way to get to it. You unclip it from the back plate. Now, typically, you only have to unclip it from the side. But like I said, this drain actually is a gravity-fed drain. It's tight, so I've unclipped the top as well on this side just a bit more, just for demonstration.
That's supposed to happen.
What's back there?
That's where you're like, yeah, baby.
That's the condenser unit that is on the other side of the wall. Yeah. Okay, so when you're actually doing this, you'll have this connection hooking up to the drain, which then comes and connects to the pan right here. And so you'll want to actually clean that out as well. Now, I will personally bring a vacuum inside, hook up, flush my pan, flush this all out. I'll take a brush, if it's gunky or nasty at all, and push it up in there and try to get that clean. So anything that I can clean is going to extend the life of my pump and help it operate better. So a pump often will fail because it's actually got so much junk built up that it's pulling in to the pump motor. And if you've ever taken one of these apart, like, it's a pretty small hole right there that everything's got to go through. So it doesn't take a lot of algae or a hard chunk of something to clog it up. Which is why in the reservoir, when you're cleaning your reservoir, you also need to make sure that you are cleaning the screen. I knew it was on here somewhere. Clean the screen, which can be in here. A lot of reservoirs will have some sort of screen, and that's to catch that algae we're talking about. Some of the big chunks from damaging the, but if that gets clogged up, then your water builds up on this side, it starts leaking in the system. Your float's not actually coming out because this has gotten so clogged that water's not coming by. That can throw off the function of your pump. And the function is your float's in here, it comes up, triggers the pump, turns it on, and then pumps it out through the tube on the other side. Now, if you're running into repeated pump issues, or you've noticed that there's a lot of algae in your system, then I would recommend hooking up to your line that actually goes outside and blowing that out as well. So you're going to want to hook up that, and that could depend on application. If you have some motor that's in the attic, only in a rare situation where I think my line's clogged am I going into an attic and opening it up and pushing air through that. But a lot of your pumps, like in this application, I'll show you cleaning this as well. You have that all right here, so then your exit pipe right here just goes up, connects to copper, and it goes downhill from there outside. And so you can unhook from here and push nitrogen through to flush that out a little bit better too. I typically on a maintenance, I'm not doing that unless I'm seeing a lot of growth and nastiness and I'm worried that, like, I've turned my pump back on, it's going slow, and I'm worried about something happening there.
Usually that small line doesn't clog because the velocity, it actually has pressure.
Mm-hmm.
So pressurized lines rarely clog. It's the unpressurized lines that clog.
Yeah, and that's all before the pump, and it builds up inside there and inside the reservoir. On this one, you have an accessible reservoir that hangs down here. These are also your louder pumps. You can often clean this a lot easier, and the maintenance is great on it. I would just, when you put it back together, typically there's going to be some foam pads that are in place to help with the vibration noise. Make sure that after you've done your maintenance, it's going back in, that edges aren't touching something hard that's going to vibrate, and foam's actually back in place. You're not making something worse by doing a maintenance, right? Okay. So I think that's good on your pump cleaning. Make sure your float is the right side back up. It's such a common problem, they went ahead and just put a sticker on this style pump. Your float switch, like this way, not this way, so that it's not falsely tripping or not going off when it should. Avoid using cleaners inside the pump when you're cleaning out the reservoir. Brian talked about this, so we will move on. Gravity drains, simple. You guys know what to do there, right? Hook up a vacuum, you dump water through. The only other thing I was going to point out on that is that your pans, you can actually remove the pans to clean them. So if there's a lot of junk that has built up on there, there's a clip on the back here where your drain, right there. So you pull that down and it slides out of the pan. And so then you can take this whole pan off of the system. So let's do that real quick. And they just unclip. And little notches on the bottom. And so there's your pan. And then you can take this and clean it out. If it's so bad where you have growth all in here, I'll just unhook it from the board right here and take it outside and spray it. And get it really clean. This part does?
All of it.
Yeah. Yeah. So instead of leaving that hanging, I'm going to go ahead and do that.
That plastic is so sturdy.
Okay, so the next thing we're going to talk about is blower wheel cleaning. Now that we've gone over cleaning our drains, our pumps. The blower wheels can get pretty nasty, and you guys have all experienced that. Dust builds up on there, and then airflow starts becoming an issue. You can get freezing. You will sometimes be pulling freeze codes. But often the customer is going to have stuff spit into their space, like little black bits, and smell weird. And you just don't got the airflow to push across the whole space and cool the whole room. So let's demonstrate taking this blower wheel off and cleaning it for you guys, okay? Here we go. Again, service manual will show you step by step what you need to do. We've already opened it up. I've demonstrated taking the pan out. There are 3 screws on this side. Let me go ahead and hang the unit up so I don't have another accident on film or something loud crashes. Put the unit back in place. That's good, right?
Well done, good and faithful, sir.
Oh, my man. Always wanted to hear that. So that is a support for the side of the coil. Over here on this side, these 3 screws. And so you can actually take the coil framing that's holding the coil in place and pull it out. And you'll need that little extra room to get your wheel out. The opposite end is still hooked up to copper. You still have all your copper tubing there. You don't just yank that around and start bending the copper that's going in there, right? There is some give, you know, a little bit of room to play around with there, but let's not get crazy. All right, so your blower wheel is going to have, in all of its fins, a slot missing. And just rule of thumb, let's make sure power's already been turned off, right? It's probably good.
That's not a rule.
Somewhere back, yeah.
Step 1.
I was gonna, yeah. Before that, so rule of thumb, whenever you're working around a running system, these fins are moving really fast and they can break if anything hits them.
So you have to be really quick.
So
with
like
it.
if you like are trying to take a temperature probe, rule of thumb on the temperature probe is not to push it in as a general rule of thumb. All right, so there's a set screw up there that can be seen through the slot in the blower. And you really just need a couple twists on that screw and you loosen it up. If it catches again, maybe we'll take another twist off. You can't always take these off, okay? If the blower wheel's been taken off in the past and someone's really cranked it down to put it back on, there'll sometimes be a notch and you just can't take it off. And that's where the bib kit comes in handy. You can clean a blower wheel with the bib kit as well. It's a lot more work than actually taking out the blower wheel because the water catches inside that wheel and just kind of spits it around a bit. There is a gasket on the back and the bearing on the inside. And once you take that out, you have a little bit of room to play with. So while it's in this area, I will try to pull it out of the, pull it off of the motor. Yeah. So again, if you do catch again on it, let's just loosen that a little bit more. Okay, so here we are again. You want to be careful with the fins of your coil and also your blower wheel. And just look how nasty that is. Am I right? One of the most satisfying jobs, cleaning this off. It cleans really well. Make it nice and shiny. There you go.
Yay. Tips for putting it back in?
Tips for putting it back in?
Just like you took it out
That's the
in
trick,
reverse.
right? How much do you put it together?
Actually, yeah, you do need a light. And so I will have my ladder nearby because you're typically up on a ladder in this situation with a light right here, just in this area, because you got to line this hole up with the inside of this motor shaft, which can be kind of tight. Oh, I'm sorry. This hole, I just pointed at the wrong side. This hole with the motor shaft. So when I'm doing that, I'll put it back in like this, and I'll look where I'm at, see how close I am, and I'll put my finger up until I can feel the end of the hole and the motor shaft that's right there, and line it up that way. Okay.
Also, it's good to put a little silicone grease on there. It's something that we should have a little bit of.
That's a great point.
Refrigeration Technologies makes a really nice silicone grease. You know, we should probably have on all
Yeah, for future cleanings, because yeah, it can.
And then the big thing is when you tighten down that screw, make sure that you tighten it down, not too tight. Tight enough, but not too tight, you know, just the right amount.
It's a pretty small screw. You can over tighten that, and you can strip it out.
And make sure you
Really
tighten
don't
down
need
in
to.
the groove on the shaft and not just anywhere on the shaft.
I'm sorry, what? Oh, right.
Yeah.
The shaft does have a little groove, so if your wheel isn't slid all the way in, I was trying to figure out what you're talking about there because it's not like a flat end. Yeah. With like a typical blower motor. But it does have a groove. So if you haven't slid all the way in, and that's another thing. Once you put it in place, line it up from side to side. Make sure you spin it with hand. Make sure it's not scraping on the edges.
Also grease the other bearing on the other side too, because that tends to get noisy if you don't. When you pull it off, if you let the grease out of that bearing.
He's talking about the one that's on the inside of the gasket.
All right, that's the bearing. That's all it is. It's just lead bearing, so you can use a little silicone grease in there, and that keeps that from happening. Because a lot of times after we clean them, there'll be a complaint about it making a noise that it never made before, and it's because that bearing is noisy.
And there's your blower wheel cleaning instruction. Okay, so in situations, this isn't every time, but in situations where you actually have a dirty coil that needs a deep cleaning, you want to use a bib kit where you can bring water and you can actually use water inside a customer's home without making a terrible mess and without messing up the equipment. So I'm going to demonstrate how to do that. Just on a normal maintenance though, there's a little buildup on the coil. You can take a rag, clean that up, or if you have like a soft bristle brush, this isn't really a soft bristle brush for that, but if you have a brush, you can typically clean up like maintenance stuff.
Another thing that I
Bib kit would
tried
be
in my
more
own
involved.
house is Evac Plus, the evaporator cleaner from Refrigeration Technologies, properly diluted, sprayed on the evap coil, and then using just a little bit of pan and drain spray in the pan when you're all done.
Yeah.
Also greatly reduces odors. I was getting kind of that funky ductless smell, and it actually,
Very good
then
point.
not, right. If you have a pump, don't do it, but, because you don't want it sitting in there. But if you do not have a pump, which the majority nowadays do not have a pump,
You smell that? Smells like,
use a little
Mary's Barn.
evap plus. Wow, you're quick.
I feel like he's still doing it.
He is.
No, I'm not.
He does what he wants. It's fine. We love him.
No. Okay, I just want to demonstrate how quick the bib kit is. All right, this is really not a big deal to bust out and install and to do. Okay, and so then your bib kit here, all the water that you've used actually pours down into that. And I'm not going to turn it on and demonstrate that because we're starting to run out of time now. But what you would typically do is you just turn this on right here. This is the Speed Clean Coil Jet. And if your angle is hard because the ceiling is so tight, then let's cover this electrical and make sure that we're actually protecting anything that might get some splash, right? But there you go. Glad we could demonstrate that. For more details on the bib kit, there are other things involved to make sure water doesn't get spilled down and make a horrible mess. You do actually have to tuck it in. You have to use the shields. So look through the full instructions on it before you actually try to use it inside of someone's home. Glad we got through that demonstration. And because it's 6:30, I'm going to go to the longest portion of our class, which is finishing up the class. Make sure that you actually leave your space clean and your equipment clean before you're done, right? Wipe down this when you've put it all back together, which you're putting it back together really carefully, making sure you're not crimping wires, making sure that everything is actually still connected the way it was. We don't just put that pan back in without hooking the wires back up, right? Everything we undid, we put it back together carefully. And that's an important part. Another important part, when you've used this, you turn the system back on with this still in place because there's a lot of water dripping and stuff and it's going to spit into the house. So I will turn it back on and just kind of hold it there, catch some of that initial. I learned one time in the master bedroom, they went in right after the maintenance, turned the system on, they stand looking at it and just all over their face. So, yeah, learned that the hard way. Okay, check for rattling noises, wipe down the inside, outside systems, make sure they're clean, clean up all your messes, move the furniture back in place, let the customer know, assure them of what you did, like let them know what you did. If they had concerns, that you address them. I looked at that, that wasn't an issue, or actually this is how that works. When the customer first comes with their issue at the beginning, okay, I'm gonna look into that. Don't immediately be like, oh, that's not actually a problem. The way that actually works, you just pull out the remote. What you're doing here is Like, that's not listening to the customer. It's like, okay, I'll look over that. And then at the end, hit all the points that you discussed with them, and that's properly closing out your call, all right? A customer is going to judge you based on their view of your detail and your cleanliness often, and your willingness to listen to them. So that's it, folks.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.